All right, so next way to check the dimensions of a web and also detect holes in it. Um, I'm using now the MLG2 Pros. These are IO-Link version. They can get them at Ethernet IP, EtherCAT, Profinet, whatever you want. A lot of different interfaces. The difference of these and the web checkers, you get a accuracy of plus or minus 0.3 millimeters. These we get down to resolution of 2.5 millimeters. So you don't get the same accuracy that you would out of the web checkers. But what is different about these is instead of us having to be a third of the distance away from the receiver, now I can be anywhere within this window. So if you look here, I've just got a piece of cardboard that I've cut out. What we're going to do is we're going to measure the width of this. And I'm going to measure the width as well, but I'm also going to detect this hole. So there's a couple different ways we can do this. One, I'll just put it up there and you can see that it's a solid object. And if I flip it around now, I can see a hole in between it. So with this variant, there's a couple different ways you can do this. One, you can do it with discrete I/O. With this variant, we get multiple QInts, so I can do a lot of different things just over discrete I/O. I've got these hooked up to an IO-Link master, so I'm pulling data over Ethernet IP. Do something very similar with a field bus module, but I don't have a field bus module now, so I just brung this data into my PLC with a SIG 350. It's an IO-Link master over Ethernet IP to the PLC. But this is the wiring diagram for it. You see I've got the T connector here, and this is the part number that I'm currently using. Response time on these is around 15.1 milliseconds. Again, depending on how many beams you have, you may take a hit with the response time. So with all that being said, right now we'll just pull Sopus back up. And right now I've got digital output 1, so I can set that to detect a hole if I wanted to. So right now you can see if I come here to anything more than 102 beams, so now no matter where it's at, it's not detecting a hole. And if I come back this way, you see now I'm detecting a hole. So again, if I block all the beams, no hole, so QInt 1 would be to tell me that. And then if I come over here, now I detect a hole because I've got more beams made. So it's the easy way. If your web's going to be the exact same size all the time, and you just want to detect if there's a hole anywhere in that span, you can do that with this function. But we've also got analog that you can put a 4 to 20 out of it, and you get the dimensions. So right now I'm doing the ID and OD. So I came down here to IO-Link interface and factor defaulted to be in light grid and RLC, or the run link code. But I can configure what data I want to come to the PLC. So I just came down here and I pulled outer dimension, digital outputs, and inner dimension is what I pulled into the PLC. And a little bit of PLC program that I've got here, I had to bring the data in and byte swap it. If you had Ethernet IP or field bus, you wouldn't have to do this. So I just bring in 3 words of data. So you'll see here where the 8900 is, that's the data coming in. So that's going to be the web size. But since I'm 2.5 millimeter beam spacing, I want an actual measurement. This will just tell me how many beams are broken, but it won't give me an actual measurement. So I did is multiply that by 25. So I've got 2.5 millimeter beam spacing, and now that gives me the actual width of the target. And then I can also down here, if you see that I'll measure the whole side as well. So here I'm across it, there's no hole. I come in now, I'm measuring the actual hole, and then I just put a little instruction here, say equal to, greater than. If it's equal to or greater than 1 beam in my ID, then I'm going to flag it as a hole detected. So I've already wrote that into a PLC, and I just put this on an HMI. So right now we see there's no web, there's no hole. And if I put it here, now I'm getting a web size, but I'm not getting a hole size anywhere across it. But if I come, let's block it all the way, and there's no hole, I bring it back. Now I know the hole size, and I know that there is a hole there. So again, just another way to be able to detect a hole in a web with the pros instead of the the web checkers. You won't get the same resolution out of these as you would out of the web checkers, but there is one good thing about it is I don't matter where I'm at inside of this. I don't have to hold that third of a distance. So anyway, just a demonstration on another way to detect holes in webs and also measure the size of the web. So let me know if you have any questions, and hope this helps.